Okay, video number 2. I would go back and do the first assignment, right triangle trig, evaluating ratios before I watch this video. So once you've done that and you've checked your answers, now you can go ahead and do what we really need to do, which is solve triangles. When you solve a triangle, you find a missing measurement. And theoretically, you could find them all if you needed to. So you're going to need to have some information, enough information, where you can write an equation using a trig ratio. So you're always thinking about SOHCAHTOA and which one you want to use. So you go to your information and you say, okay, well, that's a 32, in case you can't read that. Right, so I'm going to work with the angle I have. Now, if you wanted to, you could figure this one out down here. This is going to be 58 because these two have to add to 90. And then you can use either one. So I'm going to use the one that I was given to start with. So you're standing on this angle and you're looking out across a triangle. Like this was your yard and you were standing here looking out. This side is considered the opposite side. There's the right angle, so this is the hypotenuse, and this is the side that helps make this angle, so this is the adjacent side. So you're given the adjacent side and you want to find the opposite side. So you ask yourself the question, which one of those is it? Adjacent, opposite, TOA. So you say, well, the tangent of the angle. In this case, I know the actual measurement. Okay. Always equals what the opposite side over the adjacent side would give me. Now in this case, I don't know this fraction, so I really, in order to figure out what x is, I really need to know what it would be if I had the two sides. So what's happened in the past is some mathematician has figured out a triangle that had a 32-degree angle in it, and he's written down what the fraction would be. Right, so what you do is you go to your table of values, like a log table, but it's a trig table, and you look it up. But we don't have to do that because we have a calculator. So the first thing you got to do is make sure your calculator is in degree mode. So you go to the mode key and you look. Right down here is two different measurements for how to measure an angle. You can measure it in degrees, or you can measure it in what is known as radians. We're going to do radians fairly soon. But you want to make sure you're in degree mode. Hit enter, and then you can go back to the home screen. Now find out what the tangent of 32 would be. So tangent's right here. Tangent 32 degrees. That's the input. The output is what the fraction would be, 0.624. Now write these down, the first 4 decimal places. But just like when we're doing exponentials, we want to use the entire decimal value that our calculator gives us. So you say, okay, the tangent of 32 would always be a fraction that's equal to this decimal, approximately. And well, this is a number. So in order to solve for x, I can think about this as being over 1. I can cross multiply, or you can think about multiplying through by the denominator 13. Either way, you got x equals, because 1 times x equals this number, 0.6248 times 13. That value is right in your calculator, so just multiply that whole thing by 13, and you get 8.12, round to the nearest hundredths. So x equals 8.12, which is the length of that side. Now once you have the length of that side, you could use the Pythagorean theorem and figure out this side, or you could write another trig ratio. Okay, so again, now what you want to do is identify the sides you want to work with and then find the trig function that matches that. And so I'm standing here at the 40-degree angle, looking out across. There's the right angle, so there's the hypotenuse. It's across from there. And there's opposite. So opposite and hypotenuse is sine. So the sine of 40 degrees equals the opposite over the hypotenuse. I'll get that later. Okay, now over here what I did was find this value and write it down. Now I know it's going to come out to be a number, so if I want to save a step and not write down this decimal approximation, I can go like this. I can say, okay, I know that's a number, and I'll put it over 1. And now I'll do the cross multiply. 1 times x is x, and then this number times 18, so I'm going to write 18 times the sine of 40 degrees. And you don't really need the degree in there, but that's okay too. All right, so now I know I just have to do this, and that just saves me from having to deal with a decimal. So I just do my calculator. 18 times the sine of 40 degrees, and then I round that to wherever I want to round, 11.57. So x equals 11.57. So it's, the same process, just a different trig function. There's only one possibility that doesn't work exactly like that, and it just takes one more step. So here's a triangle. I'm trying to find my angle. There's the right angle, so that's the hypotenuse. This side helps create this angle. That's the adjacent. So let's see, adjacent hypotenuse, cosine. So the cosine of the angle is cosine of 65 degrees is always equal to the adjacent side over the hypotenuse. Okay, so now this is a number. I can think about it. Once I do the cosine, I'll get some decimal, but I'll save that till the end. If I cross multiply now, I get x times this. Okay, so x times whatever number this would give me equals, cross multiply this way, 1 times 10 is 10. Okay, well this is just a number, so once I do this I'll get this decimal. So what I can do without writing the decimal is just say I'm going to divide this side by whatever this number would come out to be. These are multiplied together. To undo multiplication, you do division. Whatever you do to one side, do to the other. All right, so these divide, leaving x, and now I just figure out 10 divided by the cosine of 65 degrees. 23.66. Okay, so those are the two possible scenarios you can get when you're trying to find the side using trig functions in a right triangle.